what if we're making a percent solution? What if you're asked for a percent versus a molarity? And that does 10% SDS, 5% SDS, 5% sugar, 10% milk, 5% milk, yes, from powdered non-fat milk, yes, for Western blots, yes. Okay, so what happens then? How do you do a percent if you have like a powder? Percent is, I get liquid, but what about a powder? Okay, so we're just going to use the formula 1 gram in 100 mils is the same as a 1% solution. And so that's how we do it in science. So 1 gram in 100 mil is 1%. Okay, so if we want a 5% solution of SDS, and we can make any volume we want to, we're going to make 100 mils because that's easy, right? So if we want 100 mils, and we want it at 5%, and we know 1 gram in 100 mils is 1%, 5 grams in 100 mils should be what? 5%. 10 grams, 10%. 2 grams, 2%. Yeah? Mm-hmm. Yay! Percent solutions. Yeah, like them. Oh, but what if we throw something else at you? What if we're not making 100 mils? Oh, we can use a formula. All right. Weight per volume percent, right? 10% weight per volume in a percentage is the weight of the solute. So this would be the gram. Oh, this would be like the grams, right? And we're going to do 100 mil of solution and then times 100, right? Isn't that how we do percent all the time? You have to multiply by 100 to get to the percent. Otherwise, you're at a decimal. Can't just move the decimal. Common Core math. You have to multiply by 100 to get percent. Okay, so let's do a practice in case that doesn't make sense. It's the same thing we did on the other page. It's just, oh, it's a formula. Okay, so let's do the mass of sugar needed if we're going to make 250 mils and we want 10%. Okay, so volume of the solution, right, times weight per volume times percent, right? So we can think of it like this. All of these things. So, right, so the grams is what we're looking for. So this, they're not making it an X because people get scared of solving for X, but this would be like solving for X. We want grams of sugar. That's what we want to figure out. How much sugar do we put in 250 mils to get a 10% solution? So we take, here's our volume, right? And then our weight per volume in percentage, so 10%. And so if we go 250 mils times 10%, that gives us 25. And so we guess that it's in grams, right? So 10% would be, right, 10%, we could also think of that as grams per 100 mil. Right, 10% would be 10 grams per 100 mil. And then look what happens if you carry your units. Ooh, because 100 mils on the bottom, we cancel these. And we're left with grams. We do 10 times 250 does not equal 25 grams. Oh, yes, it does. Wait, I forgot. We got to also divide by the 100. That gives us the 25 grams. Okay, so if you were going to make a solution, what would you do? This says you mass out. We would call it weigh out, but I guess technically it's mass and not weight, right? 25 grams of sugar, pour it into that graduated cylinder, fill it up to 250, right? That's how we make that solution. So here's another way. What if we can't remember this formula, right? What if we just can't remember this formula and we're super confused? And so we say, okay, we know, what if we just want to use this one? What if we want to use this easy way? Okay, well, if we know 1 gram in 100 ml equals 1% solution, right? We know that 10 grams in 100 mils equals 10%. Okay, right? But we want 250 mils of 10%. So we could just say, okay, we know that guy's 10%. What if we just did it again? %10 plus 10%, right? The percentage isn't going to change because we didn't just add more grams to the same volume, right? We added another 10 grams per 100 mils. So now that gives us 10% in 200 mils, right? Or 20 grams in 200 is 10%, right? 20 divided by 200, 10%, right? And then, oh, we still don't want to really do math, but if we know 10 grams in 100 mils is 10%, how many grams in 50 mils? Because right, we're at 200 mils now, but we want 250. So if 10 grams in 100, then 5 grams in 50's got to be 10%. And if we add that other 50, 100 plus 100 is 200 plus 50 is 250. That gives us our 10% in 250. And so then if we add this up, 10 plus 10 plus 5, 25 grams. Woohoo! We got the same answer. So you can just do logic by what we know and then just add it all up. If you can't remember formulas, use a noggin. Okay. Nice work, people. What else? Oh my gosh, what if you're making a complicated solution? What should we do? Panic! No, don't panic. Okay. Each chemical has its own concentration. It doesn't change the total volume. Just because you have 2 things in a solution, it's still in the 1 liter. Okay, I know that like it kind of makes your head spin around a little bit. I know it did mine way back when in the good old days. Okay, so if you want, okay, we'll just do the example and I'll just shut up. 2 molar sodium chloride, 10% SDS in the same jar, right? And we want a total of 1 liter. So our total volume is 1 liter. So we want it to be 10% SDS and 2 molar sodium chloride in this same liter. We don't want a liter of 10% SDS and a liter of 2 molar sodium chloride. We want it all together. Okay. So how do we know we need 116 grams of sodium chloride? Well, that's because on that other equation, we figured out we needed 58 grams per liter. Remember that equaled 1 molar. So we cheated a little bit. We already made a solution. We don't have to do all that math over. If we know 1 molar is 58 grams per liter, 2 molar has to be 2 times that, right? 1 molar times 2, if you multiply both sides by 2 by the same number on an equation, it's it's equal. It means the same thing, right? You can multiply by 1,000 on each side, still going to be equivalent, right? That's what this guy means. Think back to way back when in math, whatever year that was, 5th grade, 8th grade, 7th grade, right? You can do anything to either side, it means the same thing. So if you multiply by 2 on the left side, you have to multiply by 2 on the right side or it's not equivalent, right? So that gives you 2 molar. And what does it give you over here? 116 grams per liter, right? Yes, that true? If I want to make some stupid crap up, right? If I say 2 equals 2, we all buy that. That's equivalent. What if I multiplied both sides by 10? Does 20 equal 20? Yeah. What if I divide both sides by 5? Does 4 equal 4? Yeah. So you can do the same thing as long as you do it to both sides. So that's a little way to like trick that up a little bit. Okay, but now we haven't done anything with SDS, so we got to figure it out. But we want a 10% SDS solution. You know, we've already made a 10% solution before, right? What's a 10% solution of SDS? We know that equals 10%, right? Because 1 gram in 100 is 1%, 10 grams in 100 is 10%. But we don't want 100. We want a liter. How many mils is in a liter? So again, if we do something to one side of this, right? So we're really doing, oh, sorry, that looked better. We're really doing 10 grams over 100 mils. If we multiply both sides by 10, right? Again, we can do the same at the top. This gives us that 1,000 mLs, which is the same as 1 liter. And this gives us 100 grams, which is exactly what this guy said. So then we put this 116 grams of salt, and then we put in the 100 grams of SDS and the graduated cylinder and bring it up to that 1 liter. And so now we have 116 grams of salt, which is 2 mol per liter, which we already determined was 2 molar. And in that same liter, we have 100 grams of SDS. I can't circle it, which gives us 10%. So that solution has more than one solute, has the sodium chloride and the SDS, both in the same liter. Yes, yes, yes. Okay,